All right, we are live. Hey everyone, Lazy Ben. I'm getting to the point where I need to find some new music. Can't just type royalty-free music into YouTube because people might say it's royalty-free, but it's actually not royalty-free. Maybe if I'm using this Stream Beats playlist here, which is 500 songs. But I'm kind of getting a bit bored of lo-fi at the moment. Anyway, let's move on. So today, finishing off this graph, or the ability to make these graphs. So what were we doing? We've written where we wanted to begin coding. Here, right here. So binary write behavior action storage. And it needs to return a buffer. So we've got binary write brain storage. So we've got UI NPC behavior renderer. Behavior action renderer. Binary write. Okay, so we need to make a writer. It's basically the same as this. And then we pass the writer in, the name and the storage in. And then we return writer.move to buffer like that. Binary write NPC behavior action. What does that do? Nothing. So we need to implement what that does. Okay, so it's basically the same as this. Except this is get NPC behavior action types. Brill. All right. So binary read. Oh no, next one. Where were we? Here it is. Binary read behavior action storage is the same as this. But this is UI NPC behavior action renderer. Binary read NPC behavior action. And that is the same as this. Except it's get NPC behavior action types. And then the reflects. Is UI reflect NPC behavior. So this is going to be UI NPC action renderer reflect NPC behavior action reader name storage. And that's basically the same because it can accept the writer as well. Check that builds. Yeah. And then we need this internal one. NPC. So reflect NPC behavior action. And that's get NPC behavior action types. And this is just reflect NPC behavior action internal reader name behavior. And that's writer name behavior. All right, so let's compile that all up. So, how do we test all this out? Let me get back to game. We do this. We do this. We test this. We test that, I believe. And then in game brains, this is all about serializing NPC behavior action. Or just behavior actions in general. Get game reflect. All right. So really, it's here we want the breakpoints. So let's see what happens. So we should be able to save out actions now. So what's this wanting to do? It's wanting to read it. Layout members ob type for this is NPC behavior test action. So this is saving the types. Okay. So let's just remove all these breakpoints actually. So it says, has the node not been added to brain node types? So root select sequence action. So that is immediately a problem. Type hash is 0 for the node. All right. So where are we? Brain editor, brain. NPC behavior test 2. So this is right at the end of the file. Okay. The file contents. Okay, so it can't read. It's probably because they're both called. So there isn't a field here, which is the action type. So let's have a look. So read the nodes. So we're reading the title out of the root. This one, maybe. Yeah, this is a test one too. And then the sequence. So the type out of the sequence, it should be random. Random, yeah. Oh, missed one. Accidentally skipped past one there. So what's the layout now? So it skipped a lot there. I missed a bit. Let's try again. So it was the third node anyway. Oops. Right. First node, second node, third node. Okay. Type name inode. So it's in create member. So if we look at the reader here, description, yeah, okay. So this is going wrong. So we read out the description, which is nothing. And then we're going to read out the action. Type name, behavior action, layout members. So the action name is test action. This is correct. Now there's nothing else. So it calls reflect NPC behavior action. So it makes it a test action, and it unwraps it, then it's gonna load the data into it. Which is type. Now, one of the problems is, of course, that this is not here. So it's going to go to the neck. It might go to... So how does it handle this? Next token. Okay. So basically we couldn't find it. So we need to do this where we get here, which we don't do. Now the question is, do we actually, we could just put this here. I think that will be fine. Don't even have to write the word sausage. I just think we can put the word type. Right, let's see if that works. Okay, good. So now if we say, if we set this to be bacon. So that one was bacon, and we save it. So it's a second. Yeah, it's set to bacon. Okay, let's see if that loads. Bacon. Brill. Okay, so there's also, well, I think that actually concludes the new features for now. We'll check that in. There was also a problem I noticed. If I create an action node and let's put it here, and then I want to undo it, that it's not correct. I'm pressing undo over and over again now. And it eventually will disappear. So something's putting in loads of undo redo states there. I think we should try and fix that bug. So that is, let's just test where that might happen. So when we create the node, no. So when we connect the node, seems to be when we connect the node together. So push undo redo node. So there's push, undo, redo, create node. Create, remove node. So that one was working. This one, let's just do log line. Do redo nodes. I'll just see how many times this appears. Right, so if I create a node, create an action node, and we do this, we push and undo redo there. So if I move that back, that works. Connect it. Yeah, so we're only pushing it once. So what's going on there then? Why is there so many undo redo states being added? There's something to do with this. Alright. So we connect it. Undo, redo, steps, layers. There's 61 undo steps. Okay, well let's just check first. There shouldn't be that many. So create an action node, move it. So and then there's 2 undo steps now. So break when that value changes. Push step, loads of push steps. So it's gone to 3, that's fine. It's gone to 4. Push, undo, redo, focus node. Oh, so it's the focus node maybe. Okay, so this is pushing on loads. So I wonder if when we're holding the mouse over, it's pushing all the time. Not there. Yeah, look at that, it's pushing loads of undo redo. Okay. Get save checksum is not equal to undo redo checksum. I'm gonna figure out where this comes from. Let's break that off. Okay. Here. So we're calling focus node, we're clearing, if there's a focus node, so there is already focus node, push undo, clear the focus node. So it's pushing undo redo focus node over and over again. Get undo redo checksum. So if there was no focus node, do we want to focus the node? So we focus it. So what effect does that give? Is it focusing it over and over again? What is this? It's an optional. So we need to break when the value changes. It's like something is unfocusing the node. Focus node is not equal to P node. Okay. Let's put a breakpoint there again. So have a look at focus node. Nothing is focused. So what I think I might do is just do log line focus node. It doesn't know about focus node. Focus node dot has value. Yeah, that'll be good. That'll be fine. it's constantly false. That's why. We're focusing it and unfocusing it every frame. Okay. So focus node is null opt. Focus node has a value now. Very hard to debug. Okay, let's see if clear focus node gets called. Yes. Tick board panel. We're calling clear focus node here. Where is this? So if canvas is focused, the handle is focused. So if the handle is focused, okay, so this is where we're actually refocusing it again. So this focus node, I don't think actually needs to push any state at all. I think we just need to call those two. I think we just need to do that actually. Let's see what happens there. P node is just node in this situation. Let's just check that that pushes just one undo redo state. We don't need to push any actually. So this clear is doing it as well. Yeah. So we will go back to doing focus node. And we don't want to clear it. We only want to clear it if the left mouse button is up. Just down, sorry. Say if window, left mouse button, just down. Clear. Let's try that. There we go. That's fixed it. Brill, okay. So, where were we doing this? Here, wasn't it? So we can get rid of that now. That's that bug done. So the next step is we basically need to turn this graph into a game brain. So the brain editor. We have this thing called a brain here. Which is just the behavior storage. So I wonder if I should name that game brain behavior. Yeah, so we'll name that game brain behavior. Yeah. This is brain behavior storage. This does reflect NPC behavior. Okay, so let's have a look at the file. So this is actually game brain behavior. Game brain behavior. And then in the brain editor, this is not the brain, this is the behavior now. That just names the behavior. And the brain is going to be the tree. I think that is a good way to lay it out. Okay, well, we'll just load it up again and just check that it works. So game brains now. We could have game brain here now, which has a behavior and the tree. And I wonder if nodes needs events and conditions on as well. Put them on. Definitely on the root nodes, maybe on all of them. Because you want them to be able to fire events if they appear as well. How easy would it be? So if you look on the patrol editor, the node has on it events and conditions. And then when we tick the left panel, it's just events and conditions. So it wouldn't be very difficult. And then we do compiled patrol node, and that's virtual. Then we need to obviously read and write the events and conditions. But you just do events and conditions. Yeah. We'll put events and conditions in. I think. So you can have patrol nodes send individual events. patrol nodes operate on individual conditions. Sorry, not patrol nodes. That's what we were just looking at. The behavior nodes. And then in a patrol itself, it just has events and conditions on it. Brill, yeah. I'm just copying. I'm basically looking at the patrol system as kind of reference for this NPC behavior system, because they're quite similar. They do very different things, but the code layout is quite similar. So you do things like add a patrol group. So we'll add a brain group or whatever. We have these things called patrol states. It's slightly different because we can have the brain can be attached to any NPC. Whereas patrols just exist for individual NPCs. I'll get to that bit. Yeah, I think maybe you attach a game brain to an NPC, and then at every frame you just tick the brain. The brain will decide. We'll use the conditions to decide. I think that'll be the easiest way to decide what to do. Decide which actual tree to choose. Yeah. Oh man, this is a long compile. Okay. It seems like it's worked. All I want to do is test if it loaded. So we're going to add events and conditions to each node. Conditions is a little bit weird. Conditions would, for these types of nodes, probably should just determine whether they are included or not. So if a condition somehow fails, so we'll go through and we'll go, yeah, and then we'll get to here and we'll test the conditions. It won't even include it. I think that's the best thing to do. All right, so let's put conditions on. So the brain editor. So we'll look at the patrol editor as well. All right, let's just get rid of all. There's a lot of files here. Patrol editor. We'll look at the patrol editor for reference for conditions and events. So up in the brain node, we've got description, we've got events and conditions, and then when we tick the left panel, we need to make sure ticking the events and conditions. It's literally just copying this code. Let's have a quick read through. Let's check that it's fine. Okay. And then we need to write and read them. Write it. Read it. Binary. So it's descriptions, events, conditions. Description, events, conditions. All right. Now, do we need events and conditions on the individual brain? On each brain as well as on each node? We probably do. So I'll do that as well. So now each node, we should be able to add events and conditions. So we can add game event, push notify. Ooh. We'll save that and we'll just check we can load that event back up. Events 1. Cool. So each node has events. Can fire events and conditions. Quest goal achieved. So we could just basically say this only works when you are inside this trigger. Brilliant. And that we have that for every single type of node. So now we need to add events and conditions for this behavior tree to run. In general, maybe we don't need to do that because it could just be attached to the root. So we'll look at game patrols again. So you have conditions for the patrol. The patrol itself doesn't fire events. Maybe we'll do the same. Yeah. So how does that work? We just have a bunch of conditions on the patrol editor itself. So on the brain editor itself, we have conditions. I wonder if it should be in the behavior. I put it there. No, we won't. We'll put it here for now. And then on the left panel, we just want to do the conditions. And then when we save the patrol editor, we're just saving out the conditions. Save and on open. Okay. So that means we can have conditions. undo, redo. Current patrol. So what does push, undo, redo current patrol do? Nothing. Okay, so this needs to actually be push, undo, redo nodes, I think. We changed this yesterday. We can edit it, yeah. Okay, so that is also the same push, undo, redo nodes. Oops. And then here we need to do this. Conditions. So we can undo and redo the conditions. So conditions, so it's set to an enormous string. Immediately crash. So why is conditions, the size of conditions set to an enormous number? Because it was never built. Why Visual Studio? Why? All right, while this is building, I'm just going to have a 2-minute break. Okay, so if this, assuming this build fixes it, we can add conditions to where the brains even fire. Even, you know, process the trees. And what would be the next thing to do after this? We need to compile it into a game brain. So we need like we need a brain generator. We haven't written a generator in ages, which generates particular binary data for the game as an asset for the game. I think. Yeah, because we have a patrol generator. So we make a brain generator. Whoops. What did I press? The patrol generator is very small. Use a node tree loader to get the node tree out. Calls 2 compiles patrol node. So interestingly, a patrol node just has storage in it. Yeah. That's what we'll do as well. Alright, so you can have conditions now. Quest is available. 72. So we can have different brains for quests and stuff. Or we can just have different trees for quests. So we can have NPCs. We have different... So if you're in combat, or you're just normally roaming around, you can have different brains. Mint, alright, cool. So I guess now we'll think about how we're going to lay this out. So it's something like class game. Well, is it, let's look at patrol. Okay, we'll keep that here as reference. So we'll do class game brain, right? We'll just call it brain. We've called everything else game brain. We've only called game brain behavior. So we'll rename this to brain behavior. Get these names right. Everything else is called brain behavior. And we'll call this behavior storage. Oh, come on, man. Brain storage is going to be to go to behavior storage. Much whole word. Match case. Famous last words. Let's see if that builds. We did a big change there. So we've got behavior storage and behavior action storage. That seems we've called ensure brain action storage. Okay, so we'll rename these as well. Ensure behavior storage. Ensure brain behavior storage. Now we'll call it ensure behavior storage. Right. Ensure brain behavior storage. Well, I will say behavior storage, binary write behavior storage, binary read behavior storage, reflect behavior storage, and get behavior action names. Ensure behavior. Copy that. Action storage. Behavior. We've got ensure behavior. I'll get behavior names there. But that should probably be up here. Yeah, I mean, all right, good. So the editor and stuff doesn't need to necessarily know it's associated with NPCs. It just gets to the game. And behavior storage becomes NPC behavior. So this behavior in theory doesn't have to just be NPCs. So when we say write brain behavior to buffer, we're saying binary write behavior storage. This just becomes a brain. And we want struct brain node. And the brain node is going to be U64 ID. U64 type hash. And then we've got type name, which is really just a debugging thing. And then wstring description. And then we've got array children. Array engine event. Events. Array engine conditions. Then we've got dynamic storage. Well, what do dynamic storage? We'll do hybrid storage. We'll say behavior storage. We'll make it. Or we could just do something like using brain node storage equals hybrid storage. 64 bits. Brain node storage. And then we want these. And then we want a list of types of node. So brain storage types. I think. Behavior. So we'll do using and then we've got behavior root, behavior sequence, behavior selector, behavior action. And then we want static inline brain node storage types. So that is a brain node. I think. And then we want brain node serialization, which is very similar to patrol node. But the brain node. So we've got ID, type hash, type name, description, children, events, conditions, storage. So it's just the same. Mint. And then a brain. This is a class for some reason. So we've got use ID. W string name. Then we have array of brain nodes, array engine conditions, and that is what a brain is. And then we want a serializer for that. So we want ID, name, node conditions, and then game brains. So we've got something called patrol group here. But we'll stick with this. Class brain group. We've got ID and name. So this holds the brains. So we've got ID and name. And then we've got this constructor which hashes the name. And then we can compare it by name. Get brains. Get brains. Okay, so for some reason those two are not in the implementation file. These two also need to go into the implementation file. Get brains, which returns the brains. Engine condition undeclared identifier. So we want to include the BM engine conditions, include BM engine events. Behavior storage. Syntax error. What have we done there? That includes the game. How did we do this? So actually, we don't even need to do this. So this could have been why we put patrol in a separate file. So that includes the game for some reason. because we've got game, get game, reflect game condition there. Ooh, that's annoying. So the game includes game brains. Why does it include game brains for these? Because you can't forward declare these. So we made event storage. Man. Wonder what, you should be able to forward declare these. It's a shame. Yes. Need to get game brains out of here. Okay. So what have we got? We've got behavior storage and behavior action storage. If I can make that a concrete type, I can forward declare them. So we're just going to copy this. We'll do behavior action storage first. Okay, we'll do this. So this is behavior action storage, and this is behavior action storage size, and this is 64. This thing called event type here. Call this action. Sorry, action type. So Let's just check that builds. And that means this doesn't need to include game brains. It can just forward declare behavior action storage as a structure. We also need to do it for behavior storage as well. Okay, that means in the game we can forward declare behavior storage. Hopefully this builds now. This is behavior type. Go to game. Great. Let's just run this. Let's compile it and run it and just check that I haven't broken anything. Yeah, it's a shame you can't forward declare earliest types. I think you actually can't do that. I'm pretty sure you can't do that. We've got view linker errors. Reflect. Whoops. Reflect NPC behavior action. Internal. Behavior action storage. So we could do this here. We can get rid of game brains. We can just do this. And then we can include game brains here. Reflect NPC behavior action internal. Why does it not like that? Can it convert from behavior action storage to behavior storage? That's good. That actually caught a typo. Okay, let's see if we still have these linker errors. Oh. So we're just getting ready now to be able to pass the editor data, compile it into a data format that the game understands. Because the editor's just a text. The editor data is just a text file. It's just this text file here. So this all needs to get put into game data that the engine can load when the game starts. So we're going to put it in a brain object, and a brain group is going to have a bunch of brain objects, and then this is going to be the data structure that the game uses to iterate brains. This will get loaded, and then I'll be able to add things from the group into game brains, I believe. If we can move on, because there's no bugs. So we've got test action, sausage, test action, bacon. So it looks like everything loaded fine. Put a description in the root. Test description. We'll save that. And then the next step now is to make a generator. So I'm going to make up a coffee before we start this, and then we'll do the generator, which will be responsible for taking that text file and turning it into a game brain. But I'll be back in a couple of minutes. Right. Fresh bowl of coffee made. So let's look at the patrol generator. Default patrol generator. It can generate a patrol or an array of patrols. So who's calling this? Doesn't like anyone. So we've got the content cache doing stuff with patrols. Find patrol. I think that's, yeah, that's if we want, that's later. If we want to be able to regenerate the brains, which we probably would do. So who's calling reload patrol? Tick. So this is if we change a patrol file. Okay, we need to do that as well. But that's after. That's dynamic reloading of patrol files in the editor. If we launch the game directly from the editor. That's later. That's after we've done the generator. So I don't know if anyone actually calls this. Yeah, all right. Real. So we need a new file. The engine. What is it? Under tools. Where are the generators? It's in assets. It builds assets. So we're going to add a new item called default brain generator. Default brain generator. And if we look at the default patrol generator, it's quite similar. We'll include those two, and then we will forward declare brain. Is it a class? Is. So the default brain generator is going to take a name. String name. Might as well move that into the source. And this as well. Don't have a source file. Food. I like food. Get rid of that. Okay. Move that into the source. And then we just have W string view get name const. And then we're going to do bool generate const W string view path. And then this is going to be brain. Them two. So get name is just going to return the name. And then generate's going to do the work. Sorry, 1 second, I've got a message. Ugh. Trying to get into the dentist and they keep cancelling. Keep cancelling my appointment. Alright, anyway, I'll sort that out after stream. Okay. If not file exists, return false. I mean, that's a good idea. And then we just return true. Pretend we generated it. Okay. We've got a thing called the patrol group compiler. Oh, look. That's doing the array version of it. Yeah, we'll do the array version of it then. So, bool. Now they say it's not cancelled. Oh, I don't know what's going on. All right. So what is this generator doing here? It's making new ones. So we have to do array brains, which means we need to include it here. Game brains. Rather than, well, that's fine, that's good. And this does in place, so it just adds it in. It's a bit bad, that actually. It just adds one to the brains. Probably be better to just do it there. Anyway, whatever, it doesn't matter. Check that builds. Not patrols, brains. And then we need a brain group compiler. And this is the thing that hooks into the asset compiler. Brain group compiler. I believe this is header only, because it takes the generator. Oops. Brain generator. A type of generator. Generator. The default brain generator most of the time, unless you want to generate brains a different way. And it has a reference to it, and it has the files. Reference to the generator and the files. So generator get name. Okay. So this is the brain group compiler. Brain generator. Okay, so now we want template class writer bool compile writer. So this is the thing that accepts the binary data, the writer. So it's a brain group generator. Auto file in files. If not generator, generate file path group get brains, return false. Assume that works. Size t old size equals writer.get size. Turn writer.write. I'm going to write the group is not equal to old size. So the write must return the new size of the buffer. Doesn't like this. All right. And then we want get reference hash, which is the same. And all that does is it tests when the files were last written. And if the files were last written at a different time to what we have stored, it knows it needs to compile them again. Okay, so that's the brain group compiler. So let's just add that to the asset compiler. So we need include brain group compiler, include default brain generator. Right. Quest patrols, cutscenes, levels, world, sound banks. So let's do it by patrol, since we're copying that so much. So this is brains, array, asset path, brain files. And it's brain files, copy from if worker, get file path. So these are all of these raw assets. Const asset path return path as extension path.brain. So we're picking out the brain files. And then once we have all the brain files, we're going to do the default brain generator, brain base. So this is building the group. Brain group compiler. And that takes the brain generator and the brain files. And then we just do worker.compile brain base. We want a new asset type, brain group. Asset type, brain group compiler. And there we go, that should just compile all the brains up. Right. So we also need to do things in like versioning the brains. So in engine config, we need to add a new. So we want brain group version 1. So let's just look for everything we use in this patrol group. Okay. Else if type equals eAsset type brain group engine config find first brain group version result. This is unloading patrol groups and unloading, so we need to work on that as well. Right, may as well just see what happens. So let's see. Pile all this up and see. Yeah, so we're making kind of a new asset type, which is a brain group for the engine. So see if you get the brain file. So just only one brain file. Yeah, there it is. Test brain. We make the generator. We make the compiler. Brain base. So we're looking to compile a group called brain base. So the files is part of brain base. And then we compile with the worker. So we test if it needs compiling. The asset doesn't exist in the asset. So this data, a bunch of letters and numbers, BMA is the actual asset path. So it does need compiling because the asset doesn't exist. And then I'm going to run a job on a different thread and we're going to compile it. And then, so we're going to go for each file. I'm going to call it generate. So we're going to add one onto the new brains, which is completely empty. And I'm going to call generate. And here we go. So now we can take this brain file and put it in this brain. Right. That's great. So how do we do that? Let's have a look again at the patrol generator. It's reference of how to do that. So we're immediately setting the name to the path. So brain.name equals path. Now we might actually need access. So the brain, we actually need access to the default brain generator. Default brain generator needs access to the fields. Okay, that's fine. So we're going to read the file. Auto data equals file. Read UTF-8 path. And then we want a node tree loader for the brain editor. Node loader. Check we've got all those included. No. Brain editor. So we need to include the brain editor and wherever the node tree loader is. That works. Great. So we have the node loader for a brain editor, and then we do text reader. So this is just loading it out of the file. Data, node loader. So let's just see what it does there. Wanting to do a big compile again. Default layout writer does not take 3 arguments. Cannot convert behavior action storage to behavior storage again. What? What's the problem here then? Getting this error. Error. Default error writer does not take 3 arguments. This is nothing to do with what we've just written. Maybe. Oh no, it's this. It does come from the generator. Oh, so it's dynamic storage. Cannot convert from default layout writer to default layout reader. Let's rebuild that. It's a bit of a weird error because it's saying it's a different signature. No tree loader. inode. Reflect, no matching overload. Is that different error though? That's an old error. That's an old error. Here we go. Cannot convert from default layout writer to default layout reader. Oh, I think actually all I've done is that is wrong. Confusing. I wrote it wrong. Notice how the error was not given on that line. That's one of C++'s massive problems. The cause of the error was on this line, but the consequence of the error was on a different line, and it always gives the consequence of the error, or a lot of the time it does, which is nowhere near where the error was actually made in the code. Because technically you could pass a writer into there, and it would be up to me to make sure here that this was a writer, a reader, kind of reader. If you wanted to get the compile to happen here, the compile error to happen here. So assuming this builds, we will just run through and we'll just test we can load the entire node tree from the file. If we can, awesome. So the node loader has 6 nodes in it. Root brain node, and it has root, which has a title. We want an action really, because the action has in it the dynamic storage test action. Sausage, we want one that says bacon. So it's loaded that, which is empty, which seems wrong to me. Maybe it is empty. Action, test action, bacon. Yeah, I think it is empty. That final node. So one of the things as well is we need to make sure we have the behavior, which we don't. We don't get the behavior out with that. We apparently get the conditions out according to here. So let's just put a condition on. Check this asset compiler is not completely broke. Hanging. Oh, it's doing sound. It's compiling sound. It takes a while. It would have shifted a lot of data around that, adding a new asset type. So it might take a while to just compile. There we go. So let's just add a condition, a global condition. Oh, the behavior is not set. Okay. Now let's do this again. See if we have the behavior. We do. Brilliant. Brilliant. So the behavior. So we have everything we need. Okay. So we need to build this brain object now with all this data that we've got out of the file. So the brain ID. How do we? It's the asset ID. So the brain ID is the node loader asset ID. The brain.name is the path. The brain.conditions is the node loader. Could say asset name. Editor. Conditions. So the brain editor also needs to know about the default brain generator. So let's just see. So this, do we either use the path or we use the asset name? And what's the difference? So the node loader's asset name is the path. What's the path? It's the same. So we'll use the asset name. Node loader.asset name. And we want to pass on the conditions, and we also want to pass on the behavior. So a brain needs a brain behavior. Comes after name. Oops. So it's brain dot behavior equals node loader dot editor dot behavior. Let's see what happens here. When we actually copy over the behavior. And then it's just getting in the nodes and connecting them up. And we say to compiled patrol node here to actually pass over the state. Maybe we can actually test what type of node it is. Just gonna have a 2-minute break. Just gonna nip to the loo. Okie dokes. So we'll just have a quick look at see what happens when we copy storage over. Check that that is behaving. Just because it's brain behavior is its own class now. It's not a forward. It's not an alias of the hybrid storage. Okay. So we're allocating some string there. Well, that didn't give me all the information I need. I just follow this through. Ah. It's not compiled it again, man. That's super duper annoying. It's working. Says a copy of Brains was found. A copy of Brains, Game Brains was found that was different to this one. Yeah, for some reason as well, it always it's like there's a breakpoint here. Okay, so we're doing a proper copy. 0 in, copy into release. Releasing, just zeroing out the buffer, copying it into the new buffer. Yeah, that's working totally fine. All right. And now we need to just set up the nodes. So we just get the nodes. This is not an iPatrol node. This is a iBrain node. Brain node. This is brain. Got nodes. Brain node. And a brain node has all this stuff that it needs. So it needs ID. So we don't set the type hash. For some reason of patrol node. Oh, we're probably doing that here. So we might do it a little bit differently. So this is brain node. P brain node. So the type name is the title, apparently. Okay. We might try and do it a different way. So the patrol node on this occasion. So the brain node the title is not the type name. Oh, it is. It is. Root. So that just copies the basic inode. What we need to do is also copy in storage. So we can dynamic cast. Let's try this. If auto p root node equals dynamic cast root brain node p brain node. Let's just see if that works. Does. And it has the root in it, and that's the thing that we need to store in the storage. So we need to have a list of node types in the brain editor. Yeah, brain node types. So we can go for each type in Patrol Editor, no, in Brain Editor, brain node types. Copy of a p brain node. The Bit Wheel, hey, how's it going? I'm doing great, thank you. Hope you're all right. Just working on NPC behavior still. Hope your cold's a little bit better today. So try this. Stuck in bed. Oh man, that sucks. Sorry. Try and get some rest. At least you can watch a lot of Twitch. I'm just working on some data, compiling some game data right now. Going to so I can make these graphs in the editor of behavior trees, the NPCs, and now I'm putting them into game brain objects that the game can load. Yeah, nice one. Getting plenty of sleep for sure. Did you hand in your and in your assignment, coding assignment. Oh, good. Fingers crossed, hopefully. Have you got the grade back yet, or has it got to be marked? Next week. Alright, cool. Fingers crossed. It looks good to me. So we want to get the type of X. And then we can say if it's that type, P brain node, we'll call it. No, that one's called brain node. P type brain node. P actual brain node. I don't know what I should call it. Okay. Okay, so we've got the actual brain node, which is a root brain node, which has the thing in it, right? So now we need to go through the, what are they called? Do we have a list of these brain node storage types? So brain node storage types. P actual brain node, pass that in. Ooh. Yeah, so actually, we can't, I don't know if we can do this. That's a shame. We can't test what type. So iRoot node has got that in it. I mean, we could say if it's a root node, return the root node. Return root. If it's a selector node, return selector. Or we can just have a vtable thing, which is what I did for patrols. Yeah, I'll have a vtable thing. So I'll say virtual void to compiled brain node. How did this work for the patrols? Patrol node. So this is brain node output. And that'll pass in. Then we can assign the storage. Sorry. So this is void to compile brain node override and this just does output storage equals root. This one does output.storage equals selector. And this one does output.storage is sequence. And then this one does output.storage is action. Like that. And so now this can just go let's have a look at the patrol generator again. Do we just say to compiled patrol node? It's basically the same. So that's brain. That's iBrain node. To compile brain node. And that will set. So the type hash thing, that must happen here. It must set the type hash. It does. So brain nodes n type hash equals pbrain equals brain nodes n storage dot type hash. Do we not have get type hash? Brain node storage is hybrid storage. Does that not have get type hash? It does not. Wonder why. So that's usage for get hash code, return hash code, storage dot get hash code. Okay, that's going to be a big build because hybrid storage is quite far up in the code hierarchy. So if this works, we might change it so the patrol editor does it this way as well. Because they currently all have to set the type hash. Yeah. Anyway, that should compile. That should basically, the brain there should be in now. And then we can actually switch back to the game and load the brain group into the game. And then we can work on how we actually assign brains to NPCs. That's good progress. 2 hours, 42 minutes. Yeah, we'll swap over and we'll make, if this works, we will make the patrols we'll set the hash code here rather than have to set the hash, have the each patrol node individually set the hash. So for brain node as well, yeah, so it needs to test the type hash. So we've got dynamic storage serializer there as well, which I don't think is correct because that's a hybrid storage. So we want a hybrid storage serializer. That's actually passing it in as dynamic storage. So this needs to be a... That's interesting that that's actually allowed that to happen. There's not a compile error. Let's see what actually happens there. It actually makes dynamic storage out of the hybrid storage. Which I don't want it to happen. So is the game brain is serializing the nodes? Ooh. So this should get called when we pass through here. Should call here, serialize the actual storage. Needs to serialize it as hybrid storage, not dynamic storage. Dynamic storage means it would have to do a malloc and a copy. Hybrid storage, hopefully, there's no memory allocation at all. Or dynamic memory allocation. Anyway, let's just check this works first. So we're setting up the children. Oh, we're immediately crashing. Brain nodes. I think I've missed out a bracket. Yeah. Bracket misalignment there. Try again. So we get all the nodes. We set up all the children. And then for each node, we do compile brain node. We're going to store the root in storage. And then do the type hash. So the storage is type hash. Oh, we're not doing raw view on that. Need to do that. Our brain node. Sequence. Okay, good. And let's see what happens when we come to... Oh, it didn't serialize it. Didn't actually call that. So it should call write. Okay. Engine config. So let's just redo the brain group version again. So we can make it, force it to recompile. Anyway, that should all work. Then we should call write on the group, which we do nothing on. So the group can't write. Brain group. Oh yeah, we haven't actually implemented it. So it might catch it now as a compile error. What's a group have it? ID, name and brains. Okay, so let's just see if it's a compile error. This dynamic storage thing. I do want it to be a compile error. Looks like it isn't. Oh, it is. So, well, we've got a compile error. Which one was it? So this... So the brain group needs a friend. We all need a friend. we might, if this isn't a compiler error, we might work a bit on trying to make it a compiler error. Alright, that looked like a pretty insane error. Dynamic, okay, there we go, it is a compiler error, that's good. And it's decent because it's right where the error is. This is actually a hybrid storage serializer. And the space is the brain node storage size. Do we not have a size? Either. Hybrid storage size. Surely we do. Space. No, we don't. Okay, we'll put that in. Let's do that. Does that even work? Is that real syntax? Looks good. Let's check that because I don't think we've ever. Well, I think it's fine. But that should be it now. That should be. We should be able to load these brain groups back up. Somehow. I have to remember how to do it. The code base is big now, so it's like remembering how everything works is impossible. So how do we load a patrol group then? Is there a begin game, right? We do get game patrols, add patrol group, patrol base. And then it gets the asset patrol group with just a given name. So it's simple. Brilliant. That should work. So I should just be able to say like get the asset type brain group. I'm going to put a little line here. Get game brains dot add brain group brain underscore base. We need to also unload them. Empty. So if I empty a patrol group, it just basically, oh, it does that. It doesn't unload them though. For some reason. I know you can unload them. Unload patrol groups. Who's unloading them? On shutdown. Right. Yeah, I don't know if it should be in shutdown or it should just unload the patrol. Well, I suppose that unloads all the patrol groups. Yeah, because if game state adds a patrol group, so empty patrol groups, maybe that should unload them there. Nah. Keep it how it works because it's fine. This code is isn't barely touched because there's not very often you add a different asset type into the game. So I think it'll be fine. Banana. Like after we've done these brains, I don't know if there'll actually be any other asset types we need. This might be the last asset type for the entire engine. For this game project anyway. Alright. Just gonna watch this serializer. There we go. So created this serializer. And then it calls serialize on it. Type is this. Hybrid storage serializer 64. Great. So it ensures it's the type we want, and then it writes it. There we go. Root title. Okay. That's it then. Check it don't come through again, because they've not changed anything. No, it doesn't come through again. Good, right. The next thing we need to do then is work on, well, we'll check this in. 26 files there that need checking in. The next thing we want to work on is loading them back up in the game as brain groups. So what we're going to do is we're going to say the game brains, and then we want, if we look at game patrols, we want add, so he's got this E asset result, add brain group. That seems fine. And then we want to call that from game state launch. When we launch the game, or begin game, we want get game. Well, we don't even have get game brains. So game brains, get game brains. Just do static game brains. G game brains. Let's return that. So we want get game brains dot add brain group brain underscore base. And then we've got empty patrol groups. We want empty brain groups. So this, I suppose, is we have an array with a map of name to asset pointer. Interesting. I don't use maps very often. Wonder why I've done that. Weird. Doesn't really matter. So that's kind of dodgy, because that might go out of scope. What do we do with dialogue? Add dialogue, pass in a name. Yeah, so this needs to be name. So the patrol group, that needs to be name. So it doesn't, because string view doesn't. String view doesn't, might go out of scope. So let's just have a quick look and check that still works. Still compiles. So add brain group as well. Needs to be just, that just needs to be a name. All right, so what does that patrol group do? If brain groups contains name, return E asset result. Okay. Auto group equals get LST get asset, brain group, name. If group, brain groups, add name, group.get. And then we're into putting states in yet, which I don't really know if we want to do that yet. Group.error. Okay. Don't know if we want states yet. Right then, let's see if we can just load this up from the disk. The LST is the the asset management thing, which controls the interface between the game and the hard drive. Loads assets and decompresses them and things. Okay. Getting a lot of big builds at the moment. It's crazy. Don't really like it. We also need to implement empty brain groups. Don't even need to be maps. I wonder why I did map. Brain groups should just have a name. Alright, let's launch the game. Okay, so maybe it's because, yeah. Well, we need to store the asset pointer somewhere, I think that's why. So, moment of truth, can we get the group out? Yes. That was a read off disk, that. 6 nodes, so we have the behavior. We have 6 nodes. Behavior root has 1 child, which is ID 1 or index 1, which is a sequence. 2 children in 2 and 3. Yeah, looks like it worked. Brill. Yeah, so I need to think about, perhaps I don't want a map. Or will it just be fine? Oh, we'll just leave it. It'll be fine. It's not going to cause any bugs. So, groups, brain groups, empty. And then when we shut down the game again, we want to do get game groups. No, get brain groups. Get game brains dot empty brain groups. And then when we actually, that's when we end the game. We actually shut down the game. That is a crazy Visual Studio bug. We are actually saying unload patrol groups directly from the LST. So let's do void unload game of brain groups. So we just do lst dot unload brain groups, and the game shuts down. And there we are, we just have patrol groups now. Right. Not patrol groups, we have brain groups, we have brains, and they're loaded in to the game. So we need to assign. We need to be able to assign these brains to NPCs now. How do we want to do that? Obviously, we want to be able to do that with code, but we want to. It would be nice to actually do that with the editor as well. The easiest way would be an event. An event, assign brain to NPC, or assign behavior to NPC, and you give it a behavior from the drop down list in the NPC, and that fires the event which does it. I also want to be able to do it with patrols, right? So maybe we do it like this first. So Jenny's patrol. We could maybe like do default behavior here for this patrol, which could be one of these brains, and that's the default behavior for Jenny. And then when she's on patrol, she could swap behavior. When we're on an activity, she could swap behavior. Yeah. I think we'll start off by saying that Jenny will give her a default behavior. So we'll add it to the patrol, what behavior we want Jenny to have. Okay, first coffee break. Well, first checking code. And then coffee break. Be back in 2 minutes. All right then. Fresh bowl of coffee. And again. So we're going to work back in the editor to, if we open up Jenny's Patrol, and then we're on a little combo box here which says the behavior, the default behavior, so we can assign a behavior. Right. So I think we'll load up the patrol straight away. So we'd have to keep opening the file. So this is patrols, patrol base, Jenny.patrol. So that will just load up Jenny's patrol immediately. And then we need the patrol editor. And we basically want another field here. We want like the name of the patrol. So the name of the behavior. Default behavior name. Like that, I think. So we need to add all that stuff in. And when we serialize it, in, and then when we tick the left panel, we will do it before conditions. So we'll do canvas. So we'll do auto behavior names equals get game dot get behavior names, and we will do canvas draw combo box behavior. Behavior names. And we want some kind of like, I'm going to check that the behavior, we want to be able to load the behavior directly from the editor as well. So we'll do that after this. Just put a little note in. Okay. So now we can just assign a behavior, test behavior, right? Save it. Hopefully that loads back up again. test. So now it'd be nice to have a button where we could open the test behavior. All right. So this is a content cache thing, because we need to be able to basically link the test to the file name. Content cache. Figure out how this works. Yeah, I'll do this then. So I'm going to load each brain individually. Include game brains. Then we need using brain path content equals path content brain. And then we want array brain path content. Brain content. And we want a pool for it. Pool allocator. Brain 64. Brain pool. Okay. We want all these, but for path. For brains, sorry. Brain find. Need all of these. All right. Let's just close them. Then we'll open a new window. Put that over there. So we want find patrol. Let's copy patrol again with an ID. Brain content. Brain ID. Return optref brain. So with a path. Get brain, okay. So let's find brain. Default brain, generate. brain path content. This is P brain. So we use a default brain generator to generate us a new brain. Ref brain. Reload. And then get brains, we just return brain content. All right, I need to include some files here. So we need to include default brain generator. Get ID is not a member of brain. Should be. Return ID. Right. Brain path content. So what's the problem here? This is brain content. Oh. Right, so we can get rid of all these now. So we have a couple of situations. So we want to go else if path has extension path L dot brain get brain. So I'll just load the brain by path. And then if we wanted to, we want to go else if path has extension path dot brain load brain path. And where else? Is there anywhere else? So we've got find brain by brain ID, right? We want find brain by behavior name. I think. But we will. So in the patrol editor now, to left panel. So this is where we want to be next, right? So we need to get the content cache. Get content cache, right? We can do cc find brain. But we want to find it by the behavior name. So a game brain has a brain behavior, and that has the behavior name. So we could do it directly in the content cache. So we could do, so what we'll do for auto brain cc.getBrains, and then we want if brain content, brain.content, what is it? Get ID for that content. Yeah. If brain content get ID, so that's brain get ID. We want brain get behavior. Get behavior name. So that we need to return behavior. What behavior name? Is that really got to be called behavior name? I think name will be fine. Let's just have a quick look at the file because we're changing some stuff here. So this is actually called brain behavior. I believe. Yeah. We have get behavior name. Get behavior name equals behavior name, default behavior name. We have the path now. So if canvas.draw button open brain, and we can open it. Don't have to do that yet. We'll see if we get there. Right. Well, let's figure out how we open something. How do we open? Get editor window open. It's something like that. Path and camera. Yeah, it is that. It's get editor window to open. So it's get editor window open brain path. That's it. So let's see if we can open the brain back up. So you can click open brain. And there we go, it opens the test brain up. So now we can assign the behavior, the default behavior to Jenny's patrol in the editor. So in order to do that in the game, we need to go to the default patrol generator. And the patrol here, it needs a default behavior name. The name. And then we can just set it. Where do we set the patrol name? There. So it's after the loader, so we need to do patrol.default behavior name, node loader, editor, default behavior name. And then we need to rebuild the patrols. Alright, so in game patrols, now we do so. Maybe it's in game state. Tick NPC patrol. Find available patrol. Okay. So I just want to see if this patrol has a default behavior associated with it. And the next bit is to actually write what our behaviors do. Actually write the write the gubbins of a behavior tree. So I think this is going to have to be a behavior, like a brain state, and it's going to have what brain, the behavior name, and the pointer to the brain. Yeah. So there we go. So we've assigned the default behavior, right? So we'll launch the game. Oh. Okay, so patrol node. We rebuilt patrols, didn't we? Let's rebuild brains and patrols. Okay, we're crashing for some reason. An enormous count. Hey, alright, how's it going? Oh yeah.
You have a nice time.
Yeah, she had a really nice time. Yeah. So it's having a problem loading the patrol group. My expectation is it's not compiled properly here. So game state in game. It's the size of the patrol. It's reading the patrol that it can't do. Default behavior name. Let's load. So ID NPC. So it's 1, 2, 3, 4. It's the fifth one. 1, 2, 3. Forty-four. Ooh, look at that. It's Jenny Patrol. Four. Okay, that's confusing. So that's completely skipped the default behavior name. We've gone to there. Alright, let's just rebuild this. It's only take a minute or two. So it thought it was going to an array. Should have been going to try and read a string. Unless I counted wrong. Right. Ooh. It looks like it's not necessarily even recompiling the patrols there. Default behavior name is test. Default behavior name is empty. So the NPC ID, let's get that out. So that is Jenny. That is Jenny.patrol. That is 4. Look, test. Oh yeah, that 4 was just the name of the test. Okay, that worked. That one worked. It worked now. Okay, fine. I think it worked. I think it didn't compile the patrol in. That's confusing. Anyway. Let's just see if we launch this game now and we look at Jenny. She has a patrol, and the patrol has in it oh, this is a patrol state. So the patrol itself. So it's in the patrol itself. So game patrols. We add a patrol group, we make a patrol state. And then the patrol state possibly needs to patrol the default behavior. The name for the default behavior. So we'll do double string default behavior name. Well, do we need to do that? Alright, so we get the patrol, and it has a default behavior name test in it. That's good. So, I think now we'll boot straight into the game again. Editor window. So what we're going to do is in Game Brains, we're going to have a state. Probably do. So struct brain state. like this. And if you look at patrol state, got root node ID, current node ID, patrol ID, state. So we'll do a similar thing. So enum class eBrain state unavailable, available, and then we're going to have U64 root node ID, U64 current node ID, U64 brain ID, eBrain state is unavailable, and then we've got the actual root itself there. So we make a copy of the root. So what is patrol root? Get information about the patrol root. So brain root. It has the so we do need it. I don't think we need it actually. We probably do need to make a copy of the root node conditions. Yeah, we'll make a copy of the root node conditions. And then we want bool operator. Brain node ID. And that's root node ID equals brain node ID. And then we just want an array of these. States. So when we empty it, we empty the states as well. And then when we add a group, we want to actually add the states in for each root. So for auto brain group, get brains, if for each node, brain dot get nodes. If node is brain root, now was it root behavior root? Is that right? Yeah. So if it's a root node, do brain states Let's do state, place, brain state. We fill a brain state. Which is root node ID equals node ID dot current node ID dot brain ID brain get ID dot root node conditions equals node dot conditions. Okay, so it looks here like the patrol conditions aren't being tested. So much. So they're not, the patrol conditions are not actually being tested either. Interesting. So I wonder if that's going to be, we need to actually do that. So when we tick game patrols, we're just testing the root node conditions here. I think we actually need to test the patrol itself's conditions. As well. Need to figure out how to do that. Like we do have the patrol ID. I'm wondering if we should do a patrol conditions structure, which has the patrol ID and the conditions, and it can test it every frame. So it's something like struct patrol conditions. Whether it's available or not. And then we want to do say for other patrol ID. Return patrol ID is equal to the other patrol ID. And then we want an array of these. Like that. And then when we add a patrol group, we want to do add unique. And then we want patrol conditions empty. And then we actually want to tick all the conditions first. So for auto condition patrol conditions, we just want to say if every condition true, patrol.conditions patrol.state equal to ePatrol state available. Well, let's do that as well. Conditions. If conditions and conditions state equals ePatrol state available, So we'll just set it to unavailable. So I'm going to say if not conditions or control state is equal to unavailable, continue. Right, let's just test this then. What's the problem here? Add unique. So it's an engine condition. It's just patrol conditions. What's wrong? What's the problem? It's the equals. So what are we doing? We want to actually equal with itself. Well, another type is the same type. All right, let's run this and see if it does work. If this works, we can do the brains the same way. Okay, so control conditions, we've got 2. Make them both available. And it's available. Cool. There we go. So that worked. So now we need to do the same with the brains. So we need so we want brain conditions, which is the same as patrol conditions. This is brain ID. Other brain ID. This is brain state. And that's brain ID is equal to other brain ID. And that one is brain ID is equal to other brain ID. And then we want an array of brain conditions. And then we want to empty it out. Oops. Then we want to add all the brain conditions in. Same way we add brain. Get conditions. Okay. Big error. Engine conditions. What's the problem? That's engine conditions. Engine condition. Okay, cool. So we had the conditions in and the states, and then now we need to tick figure out where this, so that's in games, probably in game state. So where are we ticking the patrol? there. So we'll tick the behaviors after, before. Get game, what was it called? Get game brains dot tick. Okay, so all this is going to do is going to be very similar to patrols. It's just going to test first the brain conditions are true. And we'll set it to be available or not available. And then we're going to go through the states. We should really name this brain states, you know. And then I'm going to say if brain state is equal to eBrain state unavailable or brain state the eBrain state available. Brain state is eBrain state unavailable. Auto conditions equals brain conditions dot find brain ID. If not conditions, state eBrain state unavailable, continue. Else, if every condition true, brain root no conditions, brain.state is equal to eBrain state available. So that will turn the brains on and off, depending on the game conditions. Right. So a brain state probably should have in it the behavior name. I would say. So then when we set it up, we're just gonna go where's it? It's after state in between brain ID and conditions. So dot behavior name, get behavior name. So now we can find a brain state based on behavior name. So we're just going to do bool operator equals const w string view other behavior. I'm going to return behavior name is equal to the other behavior name. And then on brains, we're going to go optref brain state, get brain state, const w string view behavior name. And that's just going to do return brain states. Find on behavior name. Okay, so in NPC now, we basically need to start ticking NPC behavior test. We need to start ticking this somehow. So when we do tick NPC patrol, right? We maybe need to find available behavior. Wondering if we should put the default behavior name in here as well. So we'll put the default behavior name in here as well. So the W string default behavior name, and then we'll do bool operator with the behavior name. And default behavior name is equal to other behavior name. And then when we actually add the group, where did we put it? Right at the end. Dot default behavior name is equal to patrol dot default. No, I'm alright at the moment. Thanks. we want W string view get default behavior name. And that's to return the default behavior name. All right, cool. So now the game patrol has a default behavior name. So in game state, so we need to work out how to tick this brain, where to do it. So we basically need a fallback which just says like an action which is just like the default action, and if the default action is returned we just do this. Otherwise we don't do this, we take over what the NPC does. Alright, I'm just gonna have a 2-minute break, I'll be back and this is built. Alright, so the patrol has in it now a default behavior name test. So if it's not a patrol, we need to do patrol. So it's something like auto behavior. So we can do if patrol, tick behavior, return. So the behavior handles what the NPC does. Otherwise, we default it. So that has to return false. If the behavior tree just returns false, we just do this stuff. Now it'd be something like patrols, tick behavior, tick patrol behavior. Patrol. Something like that. So let's go to game patrols. So we want tick patrol behavior. That's got patrol state, patrol. And that would make that return. Yeah. So that returns false as default, right? For now. So this now has to get the behavior out the brains. So do get game brains, get brain state, patrol dot default behavior name, if not brain, return false. So there's nothing attached, we'll just return false, and it couldn't tick it. We say if not brain, or if brain state is not equal to eBrain state available, we return false as well. Brain was not available for some reason. Otherwise, we've got to tick it. So a return brain tick. Now what do we need to pass in? Like the brain doesn't know what NPC it's attached to. So maybe we need to pass in the NPC ID. So in game state again, find available patrol. So we possibly need to pass in the NPC ID as well. Oops. And that can take in the NPC ID. So game brains. So let's include game brains. And then in game state here, we need to do this again. So we obviously need a place where we can hook in new behaviors. So rather than doing brain tick, we could do get brains tick. We could do get brains dot tick NPC, passing the NPC ID. Who could get the brain state? Who could get the patrol? Could do it a different way, you know. Which gets the patrol default behavior. So we could have W string current behavior name, and then when we set that up, like that, and that's the current behavior name, and then we can change. So when the patrol wants to set a new behavior, we can do that, and we can set the current behavior name by just setting the NPC by setting the patrol. So brain state. What do we need to do? We need to get the behavior by the behavior name. So we're still in the engine here. We need to swap over to the game now. Get game. Tick NPC behavior. It's this. NPC brain or something. That would be this and NPC. Well, it would be NPC ID. This. And that would return. So maybe we don't need the tick. So you calls get game, tick NPC brain. The NPC in the brain. Okay. So on the other NPC things, so we want to do bool tick NPC brain. If they do NPC ID brain. See if it knows about brain. Does not. Brain is a class. Okay, so if auto NPC equals get game state, get NPC ID. And then we want to do, so we get the NPC. This isn't a brain either, it's a brain state. So we basically need now, whoops. So the thing is, you want to be able to put the brains per NPC, the same many brain states on the NPC itself. So how do we want to handle that? I don't think this is quite right. Yeah, so it. How do we want to do this? So this brain state here, this is one brain state, but I want to be able to attach the same brain state to many NPCs or different instances. So I'm wondering if rather than setting them up here, where do we set them up here? We create a brain state. So it'd be something like, whoops. Find, so get brain state, it'd be something like find or create brain state. So it'd be something like Octref brain state, create brain state, behavior name. So that could have multiple possible trees on it as well. So this is one brain state per root node. So this brain state is available. What we need is to create a behavior. So this doesn't have a current node ID because this is not ticked. So we're going to have the NPC So we're going to do NPC tick behavior. Let me pass in the brain. And that's Boolean as well. We return the NPC tick behavior on the brain. And what we need to know is we need to know if we have a behavior of that name. So it'd be something like struct NPC behavior. So maybe the NPC could have one of each of these. So it could have behaviors. Tick NPC for each type. Behaviors. If X get name is equal to brain dot behavior name X dot tick. And we also need to say you need to pass in the brain. So the brain is gonna, so it's a behavior. So I think what we want is we want tick behavior. with the brain and the behavior. Oh, there's going to be lots of different types of behaviors. So this needs tick NPC brain state brain. What's the problem? Cannot convert this pointer from const. Oh, because it's not const. Okay. Well, result equals false. Result equals a return result. So that will tick the right behavior given the brain. Okay. So what do we want to do here then? We want to kind of get the brain back. I want to copy the brain. Something like that. Complicated. So the NPC I think needs an array of brains in it. will include game brains. Well, it has to directly be in the NPC. Get brain. Um, all right. So we do the source brain, right? There's not a source brain. Return false. There is a source brain. If not, brains dot contains source brain. Brains dot add source brain. So actually, we should do auto index equals brains dot index of source brain if index equals brains dot get count. Oops. So this behavior is NPC brain state. Brain. It needs that. Get this compiled and I'll have to head home. That's brain state. Source brain ID. Okay, so let's just test this. So this gives the NPC, it creates a new brain for the NPC if it doesn't already exist based on the brain state. And then it get that brain and it will tick that brain that belongs to the NPC. I'm just wondering if I should separate this out to like an NPC behavior class. Unsure. All right. Tick NPC patrol behavior. Oh, I didn't even compile it. Okay. All right. I'm going to take that as a sign to stop. So I don't want to sit for another rebuild. But yeah, I'll be back on tomorrow. Around about 9:30. I'll see you later.